Yeah, yeah. Good afternoon, all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in big data, Hadoop, and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, it is visible.
Yeah. So as part of today's session, right, I'll be covering what is big data, why Hadoop and PySpark, why Hadoop, drawbacks with the current databases, why Hadoop and PySpark, drawbacks with the current databases, and PySpark, job market, right? Yes, job market, Hadoop and PySpark, job market of Hadoop and PySpark, right? Yes. What is big data? Why Hadoop and PySpark? Drawbacks with the current databases, advantage of Hadoop and PySpark, job market of Hadoop and PySpark, right? Starting with what is big data? The name itself saying, right, huge volumes of data. So currently, how the data is getting stored, like KBs of data. You see, like KBs of data, MBs of, you should have seen MBs of data, GBs, terabytes, petabytes, of like exabytes, yottabytes, sotabytes, so on, right? But you should have seen KBs, MBs, or GBs, or even TBs. But today, data is generated in petabytes. Data is generated in petabytes. Examples of petabytes of data generation. Examples of petabytes of data generation means if you take talk about any banking sector, right? Like if you take example of an SBI or HDFC, right? So within the city, you see hundreds of branches for it. Within the entire state, we see thousands of branches for it. Within the entire country, we see lakhs of branches for this, right? So again, in each branch, millions of customers, each customer making multiple transactions per hour, per day, per week, per month, and year, right? So each and every transaction has to be stored. Each and every transaction has to be stored, right? Huge transactions. Okay. Okay. Forget about this. You are aware about social media like Facebook, right? Facebook has got users throughout the world, millions and trillions of users for Facebook. How many posts and videos are getting circulated, and what is the data generated by Facebook in a minute? Not in GBs or like it will be in petabytes of data. Not only Facebook. Today, if I talk about any application, right, generating huge data that too in petabytes of data. For example, Facebook. If I talk about Twitter, generating huge data. Google queries or YouTube videos upload. What should be the storage capacity to store all the videos? Videos uploaded. What should be the storage capacity to store all this, right? Facebook, Twitter, Google, YouTube videos upload. And email messages. What should be the capacity to store all the millions and trillions of users' messages, right? Huge data. Just now I was talking about the bank transactions, right? Telecom transactions, millions and trillions of transactions, right? Or if you talk about e-commerce transactions, just if you take 1 minute of date, 1 minute of transaction, Facebook or Twitter or Google or YouTube or email, all this huge data is getting generated everywhere, right? Currently, we have got databases like currently we have got databases for storing the data, right? Like Oracle, MySQL, DB2, these things, right? These are used for OLTP operations, online transactional processing for day-to-day operations. But we have got some specialized databases. We have got some specialized databases used for data warehouse, right? Yes, specialized databases which are used for data warehouse, right? Like if you heard about Teradata, Netezza, Vertica. So these are used for OLAP for data warehouse purpose, OLAP operation, analytical processing, online analytical processing. But these databases are specialized databases. They can handle data up to some extent. But for unlimited data or for huge data, right? So as a solution to all these storage level problems and processing level problems, right? So we got a framework called Hadoop, which stores huge data and process the huge data, right? Before I come to this Hadoop services, what are the various services of Hadoop? So you need to know what are the how the data is getting generated, how is the data is getting generated, right? Yes. Observe. If you take this is the data which has been generated from the last 50 days, sorry, 50 years. This is the data in the entire current world, which has been generated from 1974 to 2024. 2024, right? This is the data which has been generated from 1974 to 2024, right? Here, if you compare the last 10 years of data with the previous 40 years of data, previous 40 years, only 20% of the data if you see, but for the last 10 to 15 years, nearly 80% of the data has been generated. If you see the total data, right, among that 80% of the data has been generated from the last 10 to 15 years. Previous 40 years, only 20%. Reasons for huge data. Reasons for huge data generation, especially from the last 10 years, because of usage of technology, usage of internet, usage of smartphones, usage of technology, usage of internet, and usage of smartphones, right? Yes. Usage of technology, internet, and smartphones. Yeah. And you can see from where, what are the main sources of this data? What are the main sources from where this data is getting generated? Mainly three sources of data. Social data, machine data, transactional data. Social data means data which has been generated from the social websites like Facebook, Twitter, all this. Machine data, data which has been generated by reading or scanning the barcodes and RFID chips. Such data we call like machine data, right? For example, if you go to a shopping mall for the items you purchase, a very huge bill is generated, right? Means by reading or scanning the barcodes and RFID chips, such data we call like machine data. Transactional data like day-to-day operations, like bank transactions, telecom transactions, and what are the various forms, various types of data. It is going to occupy like three formats of data, three types of data, right? So this whatever the huge data is generated, it's mainly of three types of data, like structured data, structured data, semi-structured data, semi-structured data, and unstructured data. Three types of data: structured, semi-structured, and unstructured. Structured data, right? Data which is organized in a structured format in the form of rows and columns. Data which is organized in the form of rows and columns in a structured format, like database, DB tables, Excel sheets. Semi-structured data, right? Yes. Which is not fully structured, which is not fully unstructured. Like XML files, JSON files, right? Unstructured, like chart messages, images, videos, raw text, all this. So mainly it is going to occupy. The biggest challenge is to handle, means if you see most of the data or the 80% of the data which has been generated, so mostly going to occupy this unstructured data. So the biggest challenge here to handle this unstructured and to process this unstructured data. But the databases can handle only structured data, which is in the form of rows and columns. So Hadoop can handle all varieties of data. Hadoop or this PySpark going to handle all varieties of data, structured, semi-structured, and unstructured, right? So as day by day data is increasing enormously, we need to have some proper storage systems, right? We need to have some proper storage systems for storing and processing the data. So Hadoop. So as a solution to all the storage level problems and processing level problems, we have got a framework called Hadoop. Is mainly meant for two things. Hadoop is mainly meant for two things: for storage and for processing. Hadoop is meant for storage and for processing. Is meant for storing and processing the data. And for storage, does Hadoop use any databases? For storing the data, no, Hadoop doesn't use any database. For storing its data, it is going with a special kind of file system, Hadoop distributed file system. Despite of the drawbacks of the databases, I said there are some drawbacks with the databases, right? Despite of the drawbacks with the databases, still Hadoop doesn't go with databases. It is going with a kind of file system, Hadoop distributed file system. And for processing, it is not using any current technology. It is going with MapReduce. Currently using with Spark, MapReduce or Spark. Yes. MapReduce or Spark. So any technology is either meant for storing or processing. So like C or C++ or Java or .NET, all these are meant for processing. To talk about Oracle, MySQL, DB2, this all this SQL server, right? All this they are meant for storage. Meant for storage. And these are meant for storage or processing, right? Yes. But these are meant either for storing or for processing. But Hadoop is meant for both storing and processing. Stores and process. So you may ask why databases are not can't be used or not used for storing Hadoop's data means we have got some drawbacks now, drawbacks with the current databases. Drawbacks with the current databases, right? Yes. Limited storage. They have got limited storage. Most of the databases, limited storage. Secondly, no parallel processing in most of the databases, no parallel processing. Most of the data, no parallel processing. And if most of the, for example, in most of the databases, right? If volume increases, volume of the data increases. If volume increases, speed decreases. For example, take a query, select total amount, means sum of amount, total, select total amount from sales table, having 10 records. See the another query, select total amount from sales to, which has got 1 lakh records. Total amount from sales one of 10 records, total amount from sales to table, which has got 1 lakh records or 10 lakh records. Say it as 10 lakh. Select total amount from sales 3. Total amount from sales 3, which has got a 10 crore records. 10 crore records. Now try to say which query is going to execute faster among these three. Which query is going to execute faster among these three, right?
And records query will execute fast.
The first query is going to get executed faster, right? Because the total amount of 10 records as compared with 10 lakh or 10 crore, right? So query to query, as the volume increases, speed decreases. Even if complexity increases, speed decreases, right? Speed decreases. Yes. But even if you see, if we take a labor example, right? If we take a labor example, it's very simple, right? If a complexity is increasing for us, speed decreases, you can say what is 3 into 4. Very simple to say what is 3 into 4, right? 12. Okay. Twelve into 4. So it is 48. But still, if you go further, 23 into 36 or 325 into 728. So here complexity increases, speed decreases. This is a labor example, but if you take the database point of view, right? If I'm taking a query like this, select the same query if I take, select total amount from sales one. If I'm taking a total amount from sales one, right? Yes. Just got 1 lakh record, 10 lakh records, 10 lakh records. Same table, same thing. See, total amount from sales one, average amount from sales one, a standard deviation of amount from standard deviation of amount from sales one. Select total amount from sales one. Select average amount from sales one. Select standard deviation of amount from sales one. Total amount from sales one, average amount from sales one, standard deviation of amount from sales one. Which query is going to execute faster among these three? Total amount from sales one, average amount or standard deviation means yes. So as compared to the first query, second query is taking more time because average, first sum to be calculated, next average to be calculated. And if you talk about the standard deviation, lot of internal processing required. Lot of internal processing is required, right? So if you talk about this query to query, yes. Volume increasing, speed decreases, right? Yes. Volume increases, speed decreases. If complexity increases, speed decreases. The major drawback with the databases can handle only structured data. They handle only structured data. They cannot handle unstructured or semi-structured data. For example, if I'm taking reviews for a particular movie, I'm taking reviews for a particular movie. Yes. User review. User one, user two, user three. In this way, 100 users have given the reviews. The first user saying 1, second one saying 0, third one saying 1. In this way, the feedback is given in the form of zeros and ones. If the movie is good, saying 1. If the movie is bad, saying 0. Can you write an SQL query for this? Can you write an SQL query for this? Selector. Selector. Review wise, single grouping, single aggregation. I want how many goods and how many not goods. I want to count. Select review wise count I want from reviews table. Group by review. You will get the output in this way. Review 1 or 0. For 1, right? Assume the count is 10. Sorry, 90. For this, it is 10. 90 people saying the movie is good. 10 people saying the movie is bad. So you are writing an SQL query and finding the count at how many goods and not. But generally, reviews won't be given in this way. They will give in their own text format, like movie is good. First person saying movie is good. Second person saying movie is not good. In this way, they are giving in their own text format, Now, can you write an SQL query to count the number of goods and not goods? Even if we are using this keyword count, it gives wrong computation. It gives wrong computation because not good has got good in it. So in this way, major drawbacks with this databases. Databases can handle only structured, cannot handle unstructured or semi-structured. Complexity increases, speed decreases. If volume increases, speed decreases. No parallel processing and limited storage. Now coming to these advantages, right? Hadoop advantages. Hadoop advantages. Unlimited data storage. First is right, unlimited data storage. And secondly, unlimited data storage is the one. Very high speed processing. Very high speed processing, right? Very high speed processing. Unlimited data storage. Very high speed processing. Can handle all varieties of data. Can handle all varieties of data. Structured, unstructured, and semi-structured. All varieties, structured, unstructured, and semi-structured. It is an open source. It is an open source. No licensing required. It is an open source. No licensing required. Unlimited data storage. Very high speed processing. Can handle all varieties. Open source. Commodity hardware. Yes. Very high speed processing because of parallel processing. Can handle all varieties, structured, unstructured, and semi-structured. So open source, no licensing required, right? Most of these Hadoop products are given by Apache. You can go to the Apache Mirrors website and you can download and you can install, right? Commodity hardware. Commodity hardware means, right? Hadoop can be installed or Hadoop can run in any system. Doesn't mean that you need to have like highly configured system. Can run on any system, right? Yes. Any hardware configuration, right? So if you see, Hadoop is proven in the market, storage point of view, processing point of view. There was many tests conducted, all right? So Yahoo has conducted a test. Yahoo has conducted a test, right? To check the speed. To check the speed of different databases. It has taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns. Sorting based on 16 columns. Mhm. Sorting based on 16 columns. So time taken by the different databases. Time taken by different databases, right? Right. Oracle has taken nearly 3.5 days to process this. MySQL. MySQL has taken nearly 6 days to process it. Oracle, MySQL, and some specialized databases used for data warehouse like Teradata has just taken 4.5 hours. Netija, another specialized data warehouse, right? That is a database used for data warehouse. It has just taken 3 hours. Finally, Hadoop has taken just 4.2 minutes. Yes, these have taken like days of time. These have taken hours of time. Hadoop has taken just minutes of time. The latest Hadoop version has taken like 1.4 minutes. So this is what the speed of Hadoop as compared with the other things, right? Very high speed processing, right? So it is proven in the market, processing point of view and even storage point of view with huge. Okay. So yes. So as part of this course, right? Yes. So four modules are going to be covered mainly, like Hadoop. There is a package like a big data package available for this. Here, Hadoop, PySpark, Spark with Python, Linux, Hadoop, PySpark, Linux, and also Python will be included in this. Python also, Python like total Python like 4 plus advanced will be, right? So, so first before this, but I'll come back to this, but before that, check the course content for this. Big data Hadoop. What is big data? Why Hadoop? Need for Hadoop sources, comparison, challenges, Hadoop ecosystem components, HDFS, Hadoop distributed file system, features of HDFS, name node, data node, secondary name node, job tracker, task tracker, metadata management, storage and processing, replication, suggest map reduce, processing domains, phases of map reduce, mapper phase, reducer phase, input split. So scoop. Scoop is one more important component, right? For importing and exporting operations. So the scoop, the the first two characters of SQL, the first two characters of this and last three characters of this forms a scoop. First two and last three just forms what? Scoop. Importing data from database, importing data from database to Hive, importing data from RDBMS to HBase, exporting data from HBase to this, exporting data from Hive to this, exporting data from HDFS, right? Transformations while importing or exporting, filtering. We can do many operations when you are importing data from other sources to Hadoop. In between, you can perform many transformations, mergings, groupings, aggregations, filtering, row filtering, column filtering, right? All this incremental import, right? Defining scoop jobs, yarn, yet another resource negotiator. So the previous drawbacks, whatever available, everything got rectified. So it has yarn, different yarn components, yarn architecture, how the processing is going to happen within the zone, right? And NoSQL, as part of this course, I'll be discussing one NoSQL database, not only SQL, not only SQL. Schemaless behavior for random access. HBase is one of the NoSQL database, right? HBase is one of the NoSQL database as going to be discussed as part of this course. Apart from that, streaming technologies, right? Like Kafka. Yes, Kafka, right? Yes, streaming data means data which keeps on incrementing, data which keeps on generating. Such kind of data, we call it like streaming data, right? So component like Kafka is going to be discussed for it. Yes. Next, the important component of Hadoop. Yes. Hive, Apache Hive, right? You have got jobs available if you have got good knowledge or command on this Hive, Apache Hive, Hive Metastore, Hive architecture, Hive query language, difference between HQL and SQL. Similar to SQL, we have got a language called HQL here. Similar to SQL, right? We have got a language called HQL, Hive query language. So it is a kind of data warehouse kind of environment in the Hadoop framework, which one Hive. So we have got how to load data from files, local files, HDFS files, tables, internal tables, external tables, working with unstructured, working with XML, working with JSON, working with URLs, weblog. Yes, insert into HDFS files, have UDF, have UDAF, have UDTF, user-defined functions, user-defined aggregated functions, user-defined tabular functions, right? Yes. Partitioned tables, non-partitioned tables, right? Partitioned and non-partitioned tables, multi-column partitioning, dynamic partitioning, non-partitioning, multi-column partitioning, dynamic partitioning in Hive, right? Dynamic partitioning in Hive. Performance tuning mechanism, right? Yes. And bucketing in Hive, indexing in Hive, like partitioning, static partitioning, multi-column partitioning, dynamic partitioning, and combination of bucketing, indexing, combination of bucketing, indexing, and partitioning with a better performance, right? Hive and HBase integration, Hive and NoSQL, right? Integrations. So this is what as part of this Hadoop it is going to be covered. But that talk of the industry, right? Like PySpark with Python, PySpark. In brief, in depth, it is going to be covered from the basics level to the advanced level, right? PySpark introduction. What is Apache Spark? Why PySpark? Need for PySpark. Its use cases, such Spark session, Spark context, repartitioning, broadcast variables, and PySpark RTD computations, and how these computations, actions, and transformations, persistence options, memory only, memory underscore SCR only, disk only, memory different persist options. PySpark core computation, PySpark core computation, fault tolerance model in Spark, different ways of creating an RTD, creating Spark objects, increasing the number of partitions, reduced by key groupings and aggregations. Single grouping, single aggregation, multiple aggregation, multi groupings, multiple aggregations, process of group by, reduce by key, various different inbuilt PySpark actions and transformations, one by one actions and transformations, what they are going to perform with some working examples. PySpark SQL data frames, different ways of So here, data frames API, PySpark creating data frame, creating an empty data frame, converting data frame to pandas, and different struct type, struct field, row class, column class, select, collect with column, drop, order by group by join, union by name, UDF map, flat map, for each field null, pivot, partition by array type, map type. PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, JSON functions, read and write JSON file, right? PySpark built-in functions. PySpark when expr lit split translate overlay timestamp to date format explode array collect list map values key values struct sum average percentage percent rank dense rank type lit PySpark external sources working with SQL statements Spark and Hive integration Spark with MySQL integration working with JSON narrow and wide transformations adding of new rows columns handling nulls, joins, window functions, writing data back to external sources, deployment modes, local mode, cluster mode, PySpark application, right? The states and tasks, driver and executors, building Spark applications, pipelines, deploying Spark applications to cluster and tuning, performance tuning, and PySpark streaming concept, integration with Kafka, and PySpark ML machine learning library, right? So apart from this Hadoop, PySpark, everything goes in the Linux environment. Linux is going to be discussed, right? Means how much knowledge required for this, not much the knowledge of Linux, not all the entire Linux, right? So how much knowledge required for this? That is going to be discussed next one. And Python also, right? That Python core and advanced, what is that basic to the advanced level of Python because total code goes in Python. So Python also, like nearly you will be having 50 sessions on Python, right? So, but Python sessions will be on normal Monday to Friday, not on the weekdays, weekend, sorry. So Python basics, what is Python, history, applications, versions, installations, flavors of Python, versions of Python, right? Python operations, modes, executions, interactive mode, different editors, IDEs, comments in Python, right? Escape sequences, strings in Python, operators in Python, right? Different operators, Python IDEs, flow control statements, looping statements, strings, collections in Python, Python lists, Python tuples, Python sets, dictionaries, functions in Python, modules in Python, modular programming or functional programming, packages in Python, errors and exception handling, object-oriented programming concepts, regular expressions in Python, database connectivity, Python datetime modules, OS modules, and like advanced concepts like iterator generator, right? GUI programming, working with Excel workbook, data analytics, some introduction to data science, the important modules of Python, pandas module, NumPy module, numerical Python, and plotting and visualizations, matplotlib. These 30 topics for Python is going to be discussed. And coming back to this package, right, which consists of Hadoop, PySpark, Linux, Python. So Python core and advanced, nearly we will be spending nearly 50 sessions on this Python. But this is going to be from Monday to this Python is going to be from Monday to Friday. So there are batches available. I'll be taking Python sessions also. You can attend any of my weekdays. On what time on weekdays means? See, Monday to Friday from tomorrow, that is uh, from tomorrow, Monday, 9 p.m. a new batch is going to start. 9 p.m. tomorrow, IST timing. Yes. Monday means day after tomorrow, right? Day after tomorrow, Monday at 9 p.m. a new batch is going to start. And that is one. And Thursday, coming Thursday at 8 a.m. in the morning, if unable to attend in the morning, that is in the evening, like morning at 8 a.m. IST, it is going to start, right? At 8 a.m. IST, it is going to start, but okay, these are the Python batches. You can attend this goes from Monday to Friday. So like 1.5 month to 2 months, these sessions will be there on Python, where you will get command on this Python. And this Hadoop PySpark Linux will be attended in the weekends. Weekends, right? Nearly it goes for 12 weekends. 12 weekends, right? In brief, in depth, we will be discussed, right? Yeah, I'm coming to your queries, right? 12 weekends, right? So 2 hours on Saturday and 2 hours on Sunday, and later whenever I go with practical, I'll be extending the sessions. we'll be having some bigger sessions too. I'll be pre-intimating. 12 weekends nearly takes for all this Hadoop PySpark and Linux to complete. So it's totally weekend batch. And the total package fees is like 15,000, 15K for this, which includes Hadoop, PySpark, Linux, and Python. And the timings of this batch, let me make it clear, right? Evening. So initially the demo will be today and tomorrow will be at, right? But the timing of this will be 7 p.m. to 9 p.m. in the evening. The timing for this will be 7 p.m. to 9 p.m. So that various, even the timings, there are many other students, right, who are not unable to attend demo today because for the US time zone, this morning somewhere like morning 4 or 4:30, like, okay. That's the reason for even for the US people to attend, right? 7 p.m. to 9 p.m. will be the timings for this. And so when some queries, right? Some queries was asked, what if you miss any class? Total Hadoop sessions. So Hadoop and PySpark, right? Mostly my concentration will be on PySpark. Nearly 7 weekends for PySpark, like 4 to 5 weekends will be there for Hadoop. 4 to 5 weekends I'll be spending on Hadoop. Nearly like 7 to 8 weekends will be there for PySpark. Yes. If you miss any class, right? Yes. Gaurav Tomar, right? Yes. Um, for all this, right? For all this Hadoop, PySpark, Linux, Python, right? Python, all this, you'll be getting the session videos. Session videos. If any session completes, that day itself, you will be getting the session video. If anybody misses the session, you can go through and attend the next session, right? Whether it's weekend or this Python, for all this Python, for all this, you'll be getting this. Yes. Installation will be shown for, yes, sir. Installation will be shown, right, for Hadoop and PySpark, right? Yes. Step-by-step installation for the Hadoop and PySpark will be discussed. Yes, because so videos only they are you can play the videos, you cannot download the videos. That option won't be provided. So timing of this, right, 7 p.m. to 9 p.m. in the evening, right? You can see a big message given by this DurgaSoft online team. Their contact details they have provided, the payment details they have provided, and this course content details also they have provided. You can just check with the course content. Yes. What is this, Anil?
Sir, Venkat here. Sir, is any Django batches will be start?
Not now. Recently, from last 1 month, 3 batches got started. That's why, as of now, from last
Okay,
1 month, like nearly 2 to 3 batches have been started, right?
okay, sir.
Okay. So tomorrow also, if people can attend the session at same time at 3 o'clock with the same link. So just I'll also be introduced. So that advantage of, I didn't discuss anything about PySpark today. Was talking about Hadoop most of that, but in tomorrow I will be just giving that advantages of PySpark, job market of this PySpark, right? Yes. I'll be discussing something about PySpark in the tomorrow's class. Tomorrow also people can attend the session to see there is a great demand, especially for this Hadoop and PySpark, especially PySpark, right? Yes, you can check in the Google, right? Even the packages, huge packages for this PySpark who has got command. That's why here, if you can check the course content, right? In brief, in depth about each and every PySpark functionality, we'll be discussing, right? With we won't be there won't be any writing huge codings here. Already many inbuilt functionalities are there. So in brief, Python will be discussed in brief, PySpark will be discussed in brief, and also the Hadoop components and this Linux, right? This will be covered, right? Any other queries, anyone? So tomorrow you can attend the session at the same 3 p.m. to see more on this one. So I'm done with your queries. If there are no other queries, I will sign off for now. Right. Meet you tomorrow. Thank you all for your time. Thank you. Meet you tomorrow.